About 5 years ago, my uncle actually died of heart failure, and he was never offered a VAD because his cardiologist said it's too expensive, the hospital can't afford it, and he died. My mother always said, if you can serve the world, do it. There's only a certain amount, less than 5,000 donor hearts available every year, with a market that's well over 1 million. So it's limited by the number of donor hearts. The blood pump technology, that's what ECMO is, extracorporeal membrane oxygenation. You have an oxygenator and a pump, you take the blood outside your body, you put oxygen in it, you put it back into the body. A VAD system, or left ventricular assist device, LVAD, is for someone that's just got left side heart failure. So you put a device, implant a device into the body, and it takes over the function of the left side of the heart, which most heart failure is. My experience at Ventricore as head of R&D, I was there for 13 years from the ground up. It gave me a good background to realise how we needed to make the device as small as possible. We needed to keep the driveline very, very thin to avoid infection. Steps we needed to do to keep the manufacturing costs down to make the device more accessible. What we've done is taking all our experience from developing that pump and putting it into a smaller profile that will actually go into the chest. And we're putting that on a single platform. If you can have a common platform where you can switch between ECMO in a hospital and a VAD, but still have the same platform, then you decrease your training costs, you decrease the infrastructure of getting the technology in and the costs associated with it. And also what's really key and important, which we didn't have at Ventricore, is the remote monitoring and the AI-assisted back-to-base cloud monitoring of the patients. The doctors can look at the data on the device and make a decision for the family whether they need to come back into the hospital or not. I'm really confident in the hydrodynamic bearing technology, its simplicity, ease of manufacture, and how it translates into real clinical gains like a thin drive line. Normally when you do a heart transplant, you have to have a sternotomy, chest is cracked open, ribs pulled back, and the heart is stopped. We've developed a suite of surgical tools, and this is going to be a first, I think, to make the operation and trauma to the patient a lot less, because we can come through the side here as a thoracotomy, and we could actually implant our device not being on bypass and with the use of these extra tools. Having gone through that regulatory journey or pathway with the technology before, and it gives me great confidence to actually take the technology and deliver it as a smaller device, but into a country like India. My latest experience in India was just an amazing experience where we went and took the concept to Kim's hospital group, which is a group that have 29 hospitals. I met their leading cardiac surgeon, Dr. Sandeep Atua, who's now on our advisory board. They were so excited about our technology and our journey that they've become our clinical partners in a way for helping develop the device. We've completed this triangle of development here in Australia with a very experienced team, manufacturing in India, and then an Indian clinical team. It completes a triangle that you need to launch the technology, and it's so exciting to be a part of that. My dream is that we put this technology, and the technology is delivered to a family that can't afford the technology, and it gives them life and quality of life. That is my dream.